Hi, grade 11, welcome back. Today, we revise together the meaning of energy levels, okay? And we will talk about classification of elements and the different types of ions. What's meant by energy levels? We know that the atom composed of nucleus and electrons, okay? Where the nucleus contains positively charged particles known as protons and uncharged particles known as neutrons. And outside the nucleus, there are electrons. Electrons revolve around the nucleus in number of energy levels, okay, with a very high speed and make a cloud around the nucleus, okay? So the energy levels imaginary places around the nucleus in which electrons revolve around the nucleus according to their energy. And the maximum number of energy levels in the heaviest atom is 7, okay? The energy level is symbolized by K, L, M, N, O, P, Q. So the first one, K, the second, L, the third, M, the fourth, N, and so on, okay? Each one differs from another in energy, okay? So the first energy level has the least energy, okay? While the seventh energy level has the highest energy, amount of energy, okay? So, and the electrons revolve around the nucleus in their energy levels according to their energy, okay? So, if the electron lies in energy level 1, okay, so it can revolve around the nucleus in K level or energy level number 1. And the electron can't transfer into higher energy level, okay, unless it gains electron, okay? When the electron gain amount of energy, okay, this is amount known as a quantum, so it can transfer from one energy level to another, from the lowest one to the higher, okay, from the low energy level to the higher, okay? So the quantum and during chemical reaction, if the electron lose the amount of energy, okay, so it can return back to its normal level, okay? So the quantum known as the amount of energy that lost or gained by electron to transfer from one energy level to another, okay? And the atom that gains a quantum of energy and the electron able to transfer to the higher energy level, this is atom, not ordinary atom, okay, but known as excited atom, okay? Excited atom. We have a rule, and from this rule we can determine the number of electrons that fill each level, okay? 2n power 2, where n refer to the number of energy level, okay? For example, the number of K level 1, the number of L level 2, the number of M level 3, the number of N level 4, okay? This is rule applied until the fourth energy level, until N level, okay? Because the atom that contain more than 4 energy levels become unstable, okay? So by apply this rule, we can determine the number of electrons added in each level or each shell. So the first one, K level, okay, saturated by 2 electrons. The maximum number of electrons in K level, 2 electrons. Okay, by apply the rule, we found that K level saturated by 2 electrons, L level saturated by 8 electrons, okay, M level saturated by 18 electrons, N level saturated by 32 electrons, okay, and by knowing each energy level saturated by electrons, okay, we can make electronic structure of the element or electronic configuration by know the number of atomic number, okay, we know the number of electrons and we can distribute electrons in the levels. Let's start with sodium. Sodium atom, okay, has 11 electrons, okay, 11 electrons. This is atomic number refer to the number of positive proton or negative electron because both of them are equal, okay? Both are equal, okay? So, from the atomic number of sodium, we can determine the number of electrons. So the number of electrons equal 11. We can distribute 11 electrons in different levels. So, K level take 2 electrons from 11, so the rest will be 9. L level can take 8 electrons from 9, so the rest will be 1 electron, the 1 electron added in M level. Okay? Another example, oxygen. The atomic number of oxygen 8, okay? And the number of electrons equal 8. We can distributed electrons, K level take from 8 2 electron. The rest will be 6, the 6 added in L level. Calcium, the atomic number of calcium 20, so the number of electrons 20 electrons distributed. K level take from 22 electrons, L level take 8, so the number the rest will be 10. M level take 8, okay, electron from 10, and the 2 electron added in L level, okay? But by the rule, we know that, by apply the rule, we know that M level can saturated by 18 electron, can carry 18 electrons, okay? Why? We put 8, okay? Because we know that each level, each energy level, okay, has sub-level or subshell, okay? And 8 electrons saturated the subshell found in M level, okay? K level contain one subshell known as S, okay? And L level contain 2 sub-levels, S, P, S and P. M contain S, P and D, okay? So in case of M level, when the S and P, okay, filled with electrons, so this is shell can be saturated and the atom becomes stable, okay? We can complete this table to practice. Also, we have another term. We have isotopes, okay? We have isotopes. What's meant by isotopes? They are 2 or more forms of chemical element, okay? Having the same number of protons or same atomic number, but the difference in the number of neutrons, so the different become in mass number. Example, hydrogen have 3 isotopes, okay? Look at the figure in front of you. They have the same atomic number, okay? They have the same number of electrons and the same number of protons, but they differ in the mass number, okay? The first one, the number of neutrons equals 0. The second, the number of neutrons equal 1. And the third isotope, the number of neutrons equal 2. So the difference in isotopes in mass number, okay, due to the difference in number of neutrons. We have another example, oxygen, okay? We have oxygen isotopes, okay? Oxygen have the same atomic number, 8 electrons, okay? 8 protons, but they differ in mass number, okay? The first one has 8 neutrons, okay? But the second at 10 neutrons. So the difference between them in the number of neutrons, so the number of mass, the mass number differ from one isotope to another, okay? Also we have isotopes of carbon, okay? Carbon have different forms, okay? Carbon 12, carbon 13, carbon 14, okay? They equal in protons, okay? All of them have 6 protons, but the difference in the number of neutrons. The first one has 6 neutrons, the second 7 neutrons, and the last one 8 neutrons, okay? Now we will talk about the classification of elements. Look at the figure in front of you. This is a figure related to the modern periodic table of the element. We know that the number of known elements until now 118, okay? The 118 element classified and in the table, okay, according to the properties and arranged in ascending order, okay, according to atomic number and the way of filling energy sublevels with electron, okay? Listen to me. 118 elements, okay, include 92 elements found in Earth crust, but the rest artificially prepared, okay? And we arrange them in the table to facilitate their study and find the relationship between elements and their properties, okay? And by looking to the table, we note that the table composed of seven horizontal periods, okay, and 18 vertical groups, okay, where the number of the period refer to the number of energy levels, okay, occupied by electrons in each element, and the number of the group referred to the number of electrons in outermost shell, okay. So by knowing the atomic number of element, we can determine its position inside the periodic table, okay. Let's start with the first one. For example, lithium, okay. By making the electronic construction of the lithium, we found that lithium has two energy levels, okay? So it lies in period 2, okay? And lithium, the last energy level, has one electron, so it lies in group 1e, okay? Another example, aluminium 13, okay? So we can make electronic configuration for aluminium. Lm, K take 2 electron, L take 8 electron, and M take 3 electron, okay? So aluminium has 3 energy levels, so it lies in period 3, okay? And it contains 3 electrons in outermost shell, so it lies in group 3, okay? In group 3, okay? Also, in modern periodic table, the element classified according to electronic structure and properties into 4 groups: metals, non-metals, metalloids, and noble gas. Okay, noble gases. Let's start with metals. Metals, they are elements that have less than 4 electrons in outermost level. Okay, the outermost level of the metal element may contain 1 electron, 2 electrons, or 3. Okay, like sodium, sodium end with 1 electron. The outermost level in sodium, 1. So sodium is metal, okay? Magnesium, the outermost level containing 2 electrons. So the magnesium is metal, okay? Aluminium end with a 3 electron. So aluminium is metal, okay? They characterized by, they are solid except mercury. Mercury, the only liquid metal in the table. The only liquid metal, okay? They have metallic luster, shining, okay? They are good conductor of heat and electricity, okay? They are malleable and ductile, can be shaped, easily shaped, okay? And metal atom, the activity of metal atom during chemical reaction, metal tend to lose electron or more and change into positive ion to be stable, okay? The atom of the element reached for the stability, okay, by reaching to the nearest electronic structure of the nearest noble gas, okay? So look at, this is a sodium atom. The sodium atom contains 11 protons and 11 electrons, okay? And this is a structure of the sodium, make the sodium unstable, okay? Because 1 electron, the outer level of the sodium not completely filled with electron, so it easily to lose the 1 electron in outermost level during chemical reaction and change into sodium positive ion, okay, where it carry number of positive charge equal to the number of lost electron, because sodium lose 1, so it carry 1 positive charge. Why? Because by compare between the number of protons and the electrons, we find that the number of protons exceed the number of electrons by 1, okay? Non-metals. Non-metals, they are elements that have more than 4 electrons in outermost level, okay? They are elements, they have more than 4 electrons in outermost level. The outermost level may contain 5, 6, or 7 electrons, okay? Non-metal may be solid as carbon and iodine, liquid as bromine, okay? Bromine, the only liquid non-metal in the table. and maybe a gas like oxygen, nitrogen, hydrogen, and so on, okay? They have no metallic luster, and they are bad conductor of heat and electricity except graphite. Graphite, another name of the carbon. Carbon or graphite is a good conductor of electricity. They aren't malleable and ductile, okay, can't be shaped, okay, and during a chemical reaction, non-metal atom tend to gain electron or more, okay, to complete outermost level and they change into negative ions, okay? Like chlorine atom contains 17 protons, 17 electrons, okay? But this is a structure unstable for chlorine atom. Chlorine atom tend to gain electron, has 7 electrons in the outermost level, okay? So it needs 1 electron to complete outermost level. So it easily to gain electron during chemical reaction and it change into chlorine negative ion. The chlorine negative ion carry one negative charge, okay? 1 negative charge, okay? Carry 1 negative charge equal to the gain the electron, okay? Because the number of protons become less than the number of negative electrons, okay? Metalloids, they are elements whose properties intermediate between metal and non-metal, like boron, silicon, germanium, arsenic, antimony, tellurium, polonium, okay? And the outermost energy level of the metalloid containing a different number of electrons, so we can't determine them from their outermost shells. Inert gas, they are elements which don't participate in chemical reaction, okay, due to the completeness of the outermost energy level, okay? Their outermost energy level contain electrons except helium, okay, because it has 2 electrons only, okay? Thank you for your good listening. Year 11, goodbye.